Hello everyone, welcome back to CodeTav Management. So this is the playlist of the backend engineering discussions. So in the last lecture of this backend engineering playlist, we have discussed about the completable future chaining. So at that time, I have told you that I will discuss the then apply and then compose again for brief discussion to understand better. So now the thing is that only. Like when we use the then apply and when we use then compose and what is the background of it. Okay, so the thing is like nowadays during your microservice application, like handling the asynchronous operations cleanly is a massive part, right, of this modern backend engineering, especially when you are dealing with the microservices and high throughput systems. So before of Java 8 we had the future interface. So that was basically clunky. Like you could start a background task, but you had to explicitly block the main thread using get method to retrieve the result. But completable future came and it basically changed the game. How? By allowing us to build non-blocking event-driven pipelines. Okay. So think this completable future like a restaurant assembly line. Like instead of standing around waiting for the chef to cook burger, you leave the instructions. When the burger is done, hand it to the person who adds the cheese. And when that's done, hand it to the person who bags it. So let's break down the mechanics, like focusing specifically on how to chain these tasks using then apply and then compose. So first of all, the then apply. Here I have written that the synchronous transformer, the map operation at that point of time use then apply. So what does it mean? So you use the then apply when you have the result of an asynchronous operation and you want to perform a synchronous transformation on top of that result. So it takes the output from that asynchronous operation, that's the previous stage, and runs a standard function on it and automatically wraps the new result back into a completable future. So think of a scenario like you asynchronously fetch a user entity from a database. And once you have it, so you want to extract their email address string. So extracting the email doesn't require another database call, as during the first asynchronous call, you already have fetched the user entity totally. So from that, you only need to fetch the user's email ID. So it's just a quick in-memory operation. So at that point of time, we can use the then apply. So here see, we have implemented we have imported the completable future from this Java util concurrent. So first in async database call is happening. So we are simulating an async database call like for fetching the user asynchronously. So here we are returning completable future dot supply async, and inside that we are returning new user ID of codestuff at the rate codetab.com. So here we are doing a heavy database work for fetching this particular email ID, the user ID of that email ID. So here you can see we are processing the user, and here we now when we have used this fetch user async this ID, we are passing this. You can see here we are passing this string user ID, right? So we are passing the 1, 2, 3. So now what is being done? Like then apply transforms the completable future user return type to completable future string, as this email ID is string type. So now this email future equals to user future dot then apply. We are using this then apply to transform it from this user type to string type. And now we are extracting the email synchronously through this user.getEmail. So this is first and blocking operation, and it is in memory operation, which is very fast. So now we are printing the result. So you got it. Like for fetching the user asynchronously, we have used this CompletableFuture.supply async, and then we are returning new user with user ID and this mail. And then here, like during the process user, we are using this fetch user async method, right? So here, like in this fetch user async, here we are doing the asynchronous call, and after the asynchronous call, from that result, we are doing one synchronous operation. Okay, cool. Now just see what is the key takeaway. Like from the then apply, we can know that the function you pass inside it should return a raw value, like a string or integer or a custom object, not another completable feature. Okay. So from that actually you are returning some raw value. Okay, cool. Now when you use the asynchronous chainer, like for the then compose, that is the asynchronous chainer. So when one will ask you about the computable future chaining, you can talk about these two things: the synchronous transformer, that is the synchronous chainer, then we use the then apply, and during the asynchronous chainer we can use the then compose. So what we use during the flat map operations, the same kind of things is happening here actually. So this is where backend architecture gets interesting. So you use the then compose when the result of your first asynchronous operation is required to trigger a second asynchronous operation. So asynchronous, then again asynchronous. In case of then apply, asynchronous, then synchronous. Okay. So in then compose, like if you were to use then apply for a second async call, you would end up with nested maze, like completable future of order, something like that, dot then compose. So that basically flattens this structure, ensuring you just get a clean completable future order. So think of a scenario like in a microservices environment, you first fetch a user ID asynchronously from an auth service. And once you have that ID, then you must make a second network call to an order service to fetch their recent purchase. So what we are doing, first of all, so here fetch user async, public class, then compose example. So here first asynchronous call for fetching the user. Next, second asynchronous call for fetching the orders. And here you need the ID from the call one. So here you can see in fetch user ID async, we are passing this string username and it's returning like this return user, this one. Now we are like in this fetch user order async, here we are returning this one plus user ID. Here we are passing the user ID. Now see, in the process workflow, we start the first async operations through calling the fetch user ID async. So there we are passing this username. So it will return this one. Okay. So now then compose change the second async operations. So here you can see this computable future string type of orders future user ID dot future then compose. Then here received ID user ID and like for CodeTav this user 9981 this ID will return. And now for this order details for user ID will be printed like this one. Okay. So for particular this, you will fetch the user order async. When you will get this user ID, then through the fetch user order async, you will pass that user ID, what you already get from the fetch user ID async. So that will be passed here. And when it will be passed, then from that you will get the order details. Okay. So now we will get the, like we are joining this order future dot join. So we will get the final result. So that will return you the completable future of completable future and order. Okay. Like completable future wrapped with another completable future. Okay. And then here order. Okay. Like this. So that basically, and here on top of that, you will use the then compose, and it will give you what? The completable future order. Okay. So it flattens the structure, ensuring you just get a clean completable future of order. Okay. So what you got this, like from this, like the function, like then compose that function, basically you pass inside it must return a completable future. It tells Java, don't wrap my result in another future. It's already a future. So just link them together, right? Now see the difference, like which one do I use? Like when you are writing your pipelines, ask yourself one questions like about the next step in the chain. Like does this next step involve any network calls or database queries or file reading or just CPU calculations? So here you can see we are hearing we have done here we have done first asynchronous call. Here we have done the asynchronous call too, and then here one network call to order service, so that is network call. So when this type of networking call or something, then we have to use this then compose. So first operation type, so then apply is basically synchronous in memory transformations, and then compose is asynchronous chained IO operations. So whenever chained IO operations, some networking call is there, then you have to use then compose. Then return type of lambda, a standard value, so that's why it's like the return type is like a string integer like that or any custom object. But here the return type is completable future. Functional equivalent, like what you have done during the Java streams with the map is like same. And for the encompass with the flat map in Java stream, what you have done. So flattening that part. So it prevents, like then apply prevents the manual threading or blocking operations. And then compose actually uh, prevents the wrapping, like nesting structure. It will remove the nesting structure and it will give you only completable future of type, this generic type. Okay. So I hope this is clear to you, which will help for your next backend engineering interviews. Okay. If you have any other question, you can ping me through comment section. Okay. And do like, share, and subscribe for more such valuable videos which will help you in future. Thank you, everyone. Bye.